In this section, we will talk about types in Reason. Reason is statically typed language. That means it evaluates types of your values during compilation time. In other words, you don't need to write your code to see if your types are correct. And you can rely on Reason's type system on 100% since it won't allow you to write any untyped code. However, having a strong type system doesn't mean you need to write types for your values all the time. If you won't write your types manually, Reason will figure them out for you. It will infer them. And thanks to this type inference, you can write your code faster and you don't lose the safety of static typing. There are 6 basic types in Reason. We have integers, floats, characters, strings, booleans, and unit. And in this section, we will talk about all of them. The only exception is unit type. But don't worry, we will talk about this type in one of the upcoming sections. So, let's get started with integers. Integers are just like whole numbers, but they also include negative numbers. So let's write our first integer. Now, when we run it, you can see it has a type of int. And Reason inferred this type for us since, as you can see, we haven't specified our type explicitly. So you can read this like 51 is a value of type int. Now, since we are dealing with integers, we can perform arithmetic operations using addition, subtraction, multiplication, or division. So let's start with simple addition. As you can see, 9 plus 3 is 12, and the result is again integer. Now, let's use more operators. Now, we get 5. Because Reason follows the usual priority rules in arithmetic expressions. And since division takes priority over addition, the result will be 5. Now, what if we try to divide 20 by 3? Now we got 6. And you need to remember that this is integer division, which means that the result of this evaluation gives you an integer and no decimal point. So the result is 6. Another important operator is modulo. Let's take a look at example. The modulo operator computes the rest of the integer division. So here, 20 is divisible by 2, so the rest is 1, and that's what we got back. Let's now try to combine modulo with other operators. Now we got 6, and this is because modulo operator has a higher priority than other arithmetic operators. So you first compute 21 modulo 2, you get 1 back, and then you add 5, so the result is 6. Now, let's talk about another Reason's basic type called float. And float must be written in a way which allows you to negate the fact that you really have a floating point number and not an integer, which means you have to use either a decimal point or an exponential. So let's take a look at examples. Now we have 2 examples here, and these are both floats. The first example is a decimal point, and the second one is exponential. Now, when performing a basic math operations in floats, we need to use an operator with a decimal point. This is how we distinguish these operations from operations with integers. So let's write an example. Now, 9.1 plus 5 is 14.1. And as you can see, we use our decimal point when we use the add operator. We write our add operator, or plus sign, with the decimal point. Let's write another example. Now we got 340. And again, we use our multiplication operator using decimal point. Now, keep in mind that you are not allowed to mix integers with floating points without using explicit type conversion. So let's take a look at the example. So we got a type error since we are mixing integers with floats together. We tried to add 4 integer to float, and it doesn't work because we are violating Reason's type system. Now let's talk about booleans. And booleans are represented by one of two values, true or false. Now let's take a look at boolean operators. We have conjunction, disjunction, and negation. And let's start with conjunction. You can think of it as a logical AND, and it's represented by double ampersand. Conjunction returns true if both expressions are true. So in our example, because both expressions are true, we get back true. Now let's take a look at disjunction. A disjunction is logical OR, and it's represented by double pipe operator. Now, if any of its expressions is true, then it returns true. Otherwise, it returns false. Now, since one of our expressions is true, we got back true. Now, let's talk about negation. You can think of negation as a logical NOT, and it's represented with an exclamation sign. Now, in this example, we negated false, so we got back true. Now, let's talk about comparison operators. And let's start with some examples. Now we compare 10 with 12, and we said that 10 is smaller than 12, so we got back true. Let's try another example. And again, we got back true because 25 is bigger or equal to 24. Now, what if we try to compare different types? For example, integer with float. Let's try that. Now we try to compare 21 with 5 point. And we got a type error since comparisons are only allowed between two values of the same type. Now, comparison operators gives you always a Boolean value. And you may compare values of any type. So that's why these operators are called polymorphic. But the two values that you compare always have to be of the same type at the time. So for example, we can do this. And we got back true. We have no type error because we first compared integers and then floats. Now let's talk about characters, another Reason's basic type. Character literals are written between single quotes. For example, you can also convert them. You can convert character to ASCII integer. So here we converted R to integer 114. And we can do also vice versa. We can convert ASCII integer to character. And we got back character R. And these methods we just used, they are built in Reason. And now let's talk about strings, another Reason's data type. And strings are written between double quotes. And many functions can be found in a standard library that are dealing with strings. For example, we have string.length, and positions in strings are numbered from 0 to its length, -1. So let's write an example. So here our first string, you can see that the Reason's compiler also inferred our type, so it's telling us it's a string. We can also concatenate two strings together. And you can see we use an infix double plus operator to do that. We can also use built-in method to get the length of the string. And you can see we got 6. And we can also use index to get a character from a string, using another built-in method, string.get. So as you can see, we first written our string and then index, so we get back E. However, we can also write this more concisely, and we have the same result. Also, you need to remember that special characters in the strings need to be escaped. You can see we got an error because we need to use double backslash to escape this. Now it works. In Reason, we can use so-called quoted string. Let's take a look. Now this special syntax for a string allows us to do multi-line string, and we don't need any special characters to escape them. It's similar to JavaScript backtick string interpolation. Now let's talk about conversions between types. Basic types in Reason are disjoint, which means that no value belongs to two different basic types. So we have no implicit conversion between types in Reason. We have this implicit type conversion, for example, in JavaScript. However, in Reason, implicit conversion would not go well with Reason's type inference. Now, if you want to have a conversion, then you have to write down the explicit conversion operator. In Reason, we have, in fact, explicit conversion operations between almost all basic data types. And if they don't exist, then it's easy to add them by ourselves. And all of these conversions are functions. So we need to write name of the function followed by the argument using parentheses. Conversion functions are defined that you first write the name of the type you want to convert, underscore, the word of, underscore, and the name of the type you are converting from. So let's first convert string to integer. So because we want to convert string to integer, we first write int, then of, and then string. And we successfully converted our string to an integer. Now, this is an evaluation which might fail if you use an argument which is not indicating an integer. Let's take a look. And you can see we got an error because Reason cannot be converted to integer because it's just a string, it's just the letters. Now, conversion functions work in both directions, so we can also convert integer to string. So we have successful conversion. We converted our integer to string. You can also do more complex operation. Let's take a look. Now we got back string. And you need to remember that function application has a higher priority than the basic operators. So we first convert our integer to string, and then we concatenate the rest of our expression. Now, let's take a look at the character conversion. To convert a string to a character, we use character index. So we got back R, character. And we can also convert a character to a string. Now, let's talk about errors. And we will take a look at the two major kinds of errors that we can get in Reason: syntax errors and type errors. And let's get started with syntax errors. Now, this phrase is correct, since it is a correct arithmetic expression. The system answers with a type which is int, and the value is 10. However, what if we omit the last integer? And this phrase is wrong on a syntactic level, since the second argument of the plus operator is missing, and the compiler answers this is a syntax error. Now let's talk about type errors. And this phrase is syntactically correct. However, it is wrong on the level of typing, since the second argument is a string when the integer was expected, and the compiler replies us with a typing error.